All right, so here is our last lesson. So remember things that you've learned from before. Notation for your derivative is f prime of x, y prime, or dy dx. Those are all the different types of ways to name the derivative. Your derivative is change in y over x, which is like your slope of a function, the slope of a tangent line, right? And also the velocity of an object at any particular moment. Hang on. All right, so remember that you already know the power rule, right? That's where you multiply the power times the coefficient and take one away from the power, right? We did that before. You already know the product rule, where if you have a product of two things, you're trying to do the derivative, you do the derivative of the first one multiplied by the original second part, then you add the derivative of the second part multiplied by the original first part. Okay, so now it's time for our last little rule for this year, and that is called the quotient rule. So when you have a quotient, so two different things here, a function divided by another function. Now our functions are mostly going to be like polynomial style functions on the numerators down there. You could have trig functions like sine over cosine or something like that, or 5x minus 2 over tangent, something like that. So next year you'll learn those. But our derivative is going to be this. So when you do the quotient rule, you notice this top part, this looks a lot like your product rule, except it has a minus in the middle. That's the only difference. And then for the bottom, you just take the original denominator and you square it, and that's it. All right, so notice a similarity to the product rule. All right, so here we go. So my derivative, so I like to basically take the denominator and put it down here, squared, so that's all done. Now for the top, I will do the derivative of the top, which is 5 times the original bottom minus then the derivative of the bottom times the original top. Oops, 5x minus 2. So the only part about the quotient rule that's annoying is that it takes some little bit of work to clean it up. So we got 15x plus 20 minus 15x plus 6, right? And that's just what's it called? That doesn't always happen, that this cancels out like that, all right? So I'm gonna get rid of that equal sign because I'm just cleaning up the top, because then I'm gonna write my derivative. I'm just going to say it's 26 over, and this bottom part, 3x plus 4 squared, we'll just leave it like that. Okay, but clean up the numerator. All right, over here, so my derivative, so I do the derivative of the top, which is actually 0, times, and I don't really need to write this because 0 times anything is just 0 here, 4x squared minus 6x plus 1, but we'll just write it, minus the derivative of the bottom would be 8x minus 6 times the top, which is 5. So this is all gonna be over the bottom, 4x squared minus 6x plus 1 squared. So that's all going to be gone. So basically I'll just be having negative 40x plus 30 on the numerator, and the bottom is just going to stay. Okay, so that is it. And so you would basically want to use this when you have a function that you can't reduce, you can't rewrite it and use one of these other rules that we had before. Okay, so I'll just do a couple more. So let's see. So let's do this guy right here. So my derivative, I'm going to write the bottom, 2x minus 1 squared. I do the derivative of the top, so that would be 3x squared minus 8x, and luckily that goes away, times the bottom, minus the derivative of the bottom, so 2 times the top. So like I said, this is just going to be a little bit annoying, so I'm just going to work this out over here. I get 6x to the third minus 3x squared minus 16x squared plus 1, right? And here minus 2x to the third plus 8x squared minus 10. All right, so let's clean that up for our answer. Put my denominator back. All right, so 6x to the third minus 2x to the third. So we got 4x to the third. Negative 3x squared, so it's negative 19 plus 8. So it's negative 11x squared. And then we got minus 9 basically. Okay, and there you have it. All right, so remember that we used to have to do the cleaning up. Like we used to turn this problem into, we divided it into each part. So you got 4, let's see, x plus 3, x to the negative 2 plus x to the negative 3, like if we split that up. So if I did the derivative now, I would get 4 minus 6x to the negative 3, and then minus 3x to the negative 4. All right, so let's go ahead and do the derivative the new way, and we'll see that they are the same. So with the quotient rule, I would get the derivative of the numerator, so that would be 32x to the third plus 6 times the bottom, 2x to the third, minus the derivative of the bottom, which is 6x squared, times the top, 8x to the fourth plus 6x plus 2, all over the square of the bottom. So if you do the bottom squared, we can go ahead and work that out. So I'm going to get that done. I have 4x to the sixth. And then up here I have, let's see, 64x to the sixth plus 12x to the third minus 48x to the sixth minus 36x to the third, and then plus, no, minus 12x squared. So if we were to clean this up, let's see. First of all, 64 minus 48, that's 16x to the sixth, that's done. Minus 24x to the third, and then minus 12x squared. All right, so let's take a look at this. If we did this, do you see how this would be 4x to the fourth, right? So what's happening here? Let me just check real quick. So we got 4x to the fourth minus, that would be 6x minus 3. All right, so why didn't those come out the same? Give me a second to think about this for a second. Oh, I see what I did and why it's not working is because I wrote 4x to the sixth here, but then I wrote 4x squared. So that should be a 4x to the sixth, right? So now I see that this is going to be 4, and then this will be, what's it called? 6, x to the negative 3, and minus 2x to the negative 4. That's 3x to the negative 4. All right, so there. So look, they match. Same. Okay. All right, sorry about that. I just made that mistake and I couldn't catch it. All right, so let's do these last two right here. So pause the video, try them yourself, and then come back. All right, so my derivative here is going to be, the derivative of the top is 2 times x minus 6, minus the derivative of the bottom is 1 times 2x plus 4, and I have x minus 6 squared. So up top I'm going to have a 2x, so 2x minus 12 minus 2x minus 4, so that's going to go away, so that'll be nice. So I get negative 16 over x minus 6 squared. All right, and then down here for this guy, f prime of x, I'm going to have the derivative of the numerator is 10x minus 2 times the bottom, x squared plus 3, minus the derivative of the bottom is 2x times 5x squared minus 2x plus 1 over x squared plus 3 squared. Now, you know, you can multiply at the bottom. I've just been leaving it there. So this guy up top here is going to be 10x to the third plus, let's see, 30x minus 2x squared minus 6. minus 10 x to the third plus, because minus and minus, 4x to the second, 4x to the second, and then minus 2x. Okay, all over the bottom. All right, so let's clean this up. These go away nicely. I got 2x squared. Then I have basically plus 28x, and then minus 6 over x squared plus 3 squared. So there is my derivative. All right, and there you have it. Oops, I just realized that you couldn't see any of that, so sorry about that. And there it is, as I was kind of talking through it there. Sorry. Okay. Okay, that's it. Bye-bye.